Here we'll look at simplifying a radical expression, problem type 1. We want to rewrite the following in simplified radical form and assume that all variables are positive, of course, because if we don't make that assumption, then we can't simplify, because the square root of a negative number is beyond the scope of algebra A. So let's take a look. Using our rule that we have used before, we know that the square root of 24v to the 8th can be broken up into its component parts. We want to look for a perfect square that goes into 24. Well, 4 goes into it nicely, so we can break that up. So we can think of this as separate problems. 24v to the 8th, the square root. Well, we can just say, oh, okay, let's simplify the square root of 24, and then let's simplify the square root of v to the 8th. Looking closely at this v to the 8th, you know, this is kind of the shortcut right here. But I want you to understand how that works. Remember, v to the 8th, the square root of v to the 8th, we could write it using this same rule that we break up the 24. We could say, oh, that's the square root of v squared times the square root of v squared times the square root of v squared times the square root of v squared, right? 2, 4, 6, 8. And v squared is a perfect square, kind of like 4 is a perfect square. It's 2 squared. So each of these simplifies into just a v times v times v times v. Okay, so again, this is the long way of thinking about it. So the square root of v to the 8th is v to the 4th. Okay, we pull both of those out in front. This is how we would write it normally. This would be how we'd write it in our answer box. 2v to the 4th square root of 6. So, looking again at this long way, you know, there's a shortcut if you notice the pattern. Inside the radical, the exponent is even, and outside the radical, the exponent becomes half of that. So, for instance, the square root of v to the 8th is just a plain v to the 4th, no more radical. Let's solidify that understanding. If we have the square root of, say, k to the 16th, well, that's just going to simplify to be a k to the 8th. There's the pattern. If we have the square root of x to the 4th, that's just going to simplify to be x squared. Here we've got the square root of 45 v to the 6th. So once again, we want to ask ourselves, are there any perfect squares that go into 45? And the answer is, yeah, 9. 9's one of them. So we could break that down into 5 times 9. And then, of course, our new rule, v to the 6th, which is the same thing as v to the 3rd squared. Or you can just think of v to the 6th, that's an even exponent. So therefore, it just is going to be divided by 2 and come out of the radical. So the square root of v to the 6th becomes v to the 3rd, and the square root of 45 becomes 3v to the 3rd. I'm sorry, 3 square root of 5. So our final answer looks like this: 3v to the 3rd square root of 5.